All right, still talking about energy and power. This time I want to talk about misconceptions. I saw this statement I've got up here. It's a definition about a terawatt that I found in a publication. And I actually wrote to the author or the people who made it, and I told them it was wrong. And let's go ahead and read it and see what's wrong about it. But it says a terawatt is 1,000 billion watts. So far, so good. Another way of saying that is a trillion watts. It says it's a quantity of energy that would require more than 500 nuclear reactors or thousands of coal-burning plants to produce. The problem here is energy. That's wrong. It's power. It's a unit of power. And people can say I'm nitpicking when I bring these things up, but this is an important difference. There's an important difference between power and energy. So that's wrong. It's actually power. Confusing energy and power is sort of like confusing distance and speed. Okay, because distance is something that we can measure with an odometer in a car, for instance, and speed is the rate of change of distance. So they're very different quantities. You know, we wouldn't say something like a mile per hour is a quantity of distance. That would be wrong to say that. So it's important that we don't mix these two terms up. 60 miles per hour we know is not a distance. It's a rate of changing distance. And so if you don't get these distinctions correct, they can lead to big misunderstandings. And so one of the problems you have with this is that we can look at a terawatt which is a trillion watts, or another way to write it is 1 times 10 to the 12th watts, or a million watts. But ultimately, it's 1 trillion joules per second. And that's quite a bit different than a joule. So let's look at some of the things, the interesting things that can happen when we confuse watts and joules. Okay, so let's look at a scenario where we might be able to get 1 trillion watts of energy generated from a AA battery. Imagine I take a AA battery and I charge a capacitor, and I store 1 joule of energy. Now, since power is a rate, then I can use rates in which the denominator is a number much bigger than 1, but I can also use denominators that are much smaller than 1. So if I have a joule of energy in the capacitor, if I discharge it over 1 second, that's 1 watt. But if I discharge it over a trillionth of a second, that equals 1 trillion watts. Now notice it's a trillion watts, but I'm not generating it for a very long period of time, but nonetheless it's a trillion watts. So a lot of times what people do with this kind of ignorance that people have about energy and power is they take advantage of that. And I'm going to have some other topics that regarding how people are taken advantage of not knowing the difference between energy and power.